Okay, motion and differentiation. Hopefully this video is going to be a lot quicker than the last one. Sorry about that. All right, so you know that x is displacement. For this question, the equation of motion of a particle is given by x equals 2 cos t, where x is in metres, the displacement, and t is in seconds. Draw a neat sketch of this equation for t between 0 and 2 pi. So you can see these questions build on trig functions. All right, so what is the amplitude of this graph? Well, the amplitude you can see is 2. And what is the period? The period you can see is 2 pi on 2, which is going to be pi. 2 pi on 2, which equals pi. So we have one period from 0 to pi, and then we're going to have another period because we have to draw all the way up to 2 pi. So let's draw in our axes. This x-axis is going to be t. The y-axis is going to be our displacement, x. Okay, we don't really need negative values of t because t is not going to be negative. Alright, so when, let's draw this. When t equals 0, here you get 2 times cos of 0. Cos of 0 is 1 times 2 is 2. So we're going to start up at 2. We should probably mark in our x values because we want to draw from 0 to 2 pi. So we'll make this 2 pi, which means we're going to make that pi. We'll go halfway to pi on 2, which makes this 1 pi on 2, 2 pi on 2, 3 pi on 2. And hopefully that'll be enough to draw it. No, probably not. Let's go halfway again. Pi on 4, 3 pi on 4, 4 pi on 5 pi on 4, 6 pi on 4, 7 pi on 4. And that last one was probably a little bit too close. Alright, so I'm just going to draw dots. So we're going to start up here at 2. Now our period, remember, is pi, so we have to repeat and get all the way back up there at pi. So actually the way that I just did it was the way that it needs to be. So we're going to go through here. Pi at 2, we're going to be down here at -2. Up again, back through 0, and then finishing at 2. And then we're going to repeat that through there, down there, through 0, and back up to 2. So drawing our cosine curve. Oh, that was terrible. Oh, that was a quick way of replacing it. Oh, it erased our dots. My dots. There we go. So there is the graph of our displacement versus time for t in between 0 and 2 pi. Part B, write down the velocity and the acceleration. Okay, so remember velocity is the first derivative. So differentiating 2 cos 2, cos goes to negative sign, and we've got to differentiate the 2 there. So it's going to be -4 sine 2t, and our acceleration, we will do that in purple, differentiating that again, and you're going to get -8 cos 2t. Okay, then part C, what is the initial displacement of the particle? Well, you can use your graph actually, or you can use the equation to work this out. Using the graph, initial displacement means when t equals 0. When t equals 0, remember this is the graph of our displacement, so let's see what the displacement is, and it's 2. The initial displacement of the particle is 2 meters to the right. Okay, that's pretty easy. Or you could substitute in t equals 0 there, which is what we did earlier. So initial displacement is 2 meters to the right of the origin. And the next question, sorry about my writing here, part D, what is the initial velocity? Remember, velocity is the gradient function. There's the equation there. Well, you can actually read this off the graph as well. What is the gradient right there? Well, if you were to draw a tangent in there, you can see the tangent would be horizontal. It's a turning point. So the gradient right there is 0, which means the velocity is 0. If you were to sub in t equals 0 into the equation, here you get negative 4 times sine of 2 times 0. 2 times 0 is 0. Sine of 0 is 0 times negative 4 is still 0. So the velocity, the initial velocity is 0 meters per second. Alright, E. Find the times where the particle is at rest and where is it at those times. Alright, so the particle is at rest, using our graph again, I guess we could. Particle is at rest when the velocity is 0. The velocity is 0 when, if we were to use our displacement graph, we can use this to work out the velocity, because the velocity is the gradient function of this, and the velocity is going to be at rest, the particle is at rest when the velocity is 0. Velocity is 0 at our turning points, there, there, and there. So it says find the times. So the time is going to be t equals 0, t equals pi on 2, t equals pi, t equals 3 pi on 2, and t equals 2 pi. And where is it at those times? It is 2 meters to the right, 2 meters to the left, 2 meters to the right, 2 meters to the left, and 2 meters to the right. So the times at rest when t equals 0, pi on 2, pi, 3 pi on 2, and 2 pi seconds. And it is at plus or minus 2, 2 meters to the right or 2 meters to the left. Alright, and then part part F. What is the maximum displacement of the particle? Well, you can see from the graph the maximum displacement is it's going in between, it's oscillating between 2 and negative 2. So the maximum displacement is 2 meters. Okay, so we actually used the graph to answer a lot of those questions, but like what we could have just, if we didn't have the graph, we could have just used all the equations that we had, the equation for displacement, the equation for velocity, or the equation for acceleration. Are very similar. Now the trig function is just been shifted quite a lot more. X equals 2 minus 2 cos 2t. We have to sketch x as a function of t. So we have to sketch this function. So it might be actually easier to sketch a couple of other functions that build up to this function. So why don't we first sketch 2 cos 2t, then we could sketch maybe negative 2 cos 2t, and then we just have to, this 2 here means we're going to shift it up by 2. Alright, so let's sketch 2 cos 2t. What is the amplitude of this graph? Well, the amplitude you can see is 2, and the period is going to be 2 pi on 2, which is pi. So let's draw our axes in. Yeah, we'll do it here and here. Put 2 there, 4 there, 2, 4, negative 2, negative 4. And we need to draw this between 0 and 2 pi. So we'll make that 2 pi. Halfway will be pi. Halfway again will be pi on 2, which makes this 3 pi on 2. And halfway is pi on 4, then we've got 2 pi on 4, 3 pi on 4, 4 pi on 4, 5 pi on 4, 6 pi on 4, 7 pi on 4. Okay, so on the x-axis we have t for time, and on the y-axis we have x for displacement. So we're going to draw a couple of build-up functions, I guess you could call them, before we draw our displacement function, 2 minus 2 cos t. So first let's draw 2 cos 2t. So that is going to start at 2. The period's pi, so it's going to end back here at 2. It's going to come down through 0, down to negative 2, back up through 0 and finish there. So there is 2 cos 2t. Okay, so we'll just maybe put that in as x equals 2 cos 2t. But see how the equation that we want is 2 minus 2 cos 2t. So let's draw, oops, not y equals, let's draw x equals x equals, sorry, I don't know where I'm out, there we go. No. No. Okay, we want to draw x equals negative 2 cos 2t. So what's the difference between 2 cos 2t and negative 2 cos 2t? Well, it's just going to be flipped about that x-axis. So every x value that was originally positive becomes negative, and every value that was negative becomes positive. So we're going to start down here at negative 2. Go up this way. So this is really should just be a reflection about the x-axis. Alright, now the actual graph that we want to draw though is x equals 2 minus 2 cos t. X equals 2 minus 2 cos 2t. Alright, what is the difference between this purple graph and this red graph? Well, it's very similar. It's got those parts the same. It's just got this extra little plus 2 at the beginning. So we're shifting the purple graph up by 2 to get the red graph, which is the one that we wanted. So all the x values from the purple graph are shifting up 2. So just like this, you can see I'm shifting all the purple values up 2. And then that'll end there. So that's one way of drawing some trig graphs, by building up from other functions. Alright, so that's part A, sketch x as a function of t, for t between 0 and 2 pi. Alright, find the times, B, find the times when the particle is at rest and where the particle is at those times. So, our particle is at rest when the velocity is 0. The velocity is the gradient function. Where is the tangent where is the gradient of the tangent 0 on this red curve? Well, you can see it's going to be right there. The gradient of the tangent would be 0. At 0, pi and 2, pi, 3 pi and 2, and 2 pi. So at all our turning points, the particle is going to be at rest. And where is it at that time? It's going to be here at 0 at the origin, 4 meters to the right of the origin, back to the origin, 4 meters to the right of the origin, or at the origin. So that's the answer for part B. At rest, when t equals 0, pi and 2, pi, 3 pi and 2, and 2 pi. And it is at the origin or 4 meters to the right. Of the origin. Okay, part C. What is the maximum distance of the particle from O? Well, you can see we kind of answered that in B. You can see the maximum distance is 4 meters to the right of the origin. Part D. Draw a neat sketch of the velocity equation. Ooh, okay, we need a new colour here. So, green, velocity equation. Well, what is the velocity equation? Let's find what it is first. Let's differentiate the displacement. So the derivative of 2 is 0. So the derivative of then we're differentiating negative 2 cos 2t. Well, cos goes to negative, so but that negative there times a negative makes it a positive. So then you're going to have positive 4 sine 2t. So we need to sketch this curve, or a neat sketch. So our amplitude, you can see, is 4. And our period is also 2 pi on 2, which is pi. So remember, sine graphs always start at 0. So and then we're going to end back at 0 when t equals pi, because we got one period there. And we'll end back in the middle here. Sine goes up first, so it's going to go all the way up to 4, and then back down to negative 4. So here's our velocity graph. And then we're going to have one more period between 0 and 2 pi. It's going to go up to 4 and down to negative 4. Oh, what's happening there? Sorry. So there's our velocity graph. Part E, hence or otherwise find when the particle is first moving with greatest velocity and its acceleration at this time. That's greatest velocity. So we can use our green graph to find where the greatest velocity is first. So our velocity there is 0, and then our velocity is 2, and then our velocity is 4, and then it comes down. So our greatest velocity is going to be 4. It says find when the particle is first moving with greatest velocity. So that value there is pi on 4. So it's first moving with greatest velocity when t equals pi on 4, and its acceleration at this time. So what's its acceleration right there? Well, the acceleration, remember, is the gradient function of velocity. What's the gradient of the tangent right there? The gradient of the tangent is 0. Okay, so it is first moving with greatest velocity when t equals pi on 4 seconds. And this is when the acceleration equals 0. Okay, and you could have also worked that out by finding an equation for the acceleration by differentiating the velocity function. So that would be 8 cos 2t. And if you sub in t equals pi on 4 there, you would get 8 cos 2 times pi on 4. What is 2 times pi on 4? Pi on 2. Cos of pi on 2 is 0, so the acceleration is 0. It's another way of working it out. That's it.